Ever get that feeling like we only see the tip of the iceberg when it comes to the ocean? I mean, it's huge out there. What's going on beneath the surface? What's really happening? Turns out, more than we realize, especially with ships that go dark on purpose. Today's deep dive is all about these dark vessels and the almost sci-fi tech being used to find them.
It's a fascinating intersection of maritime security and artificial intelligence, yeah.
Yeah.
Real-world implications for everything from smuggling rings to overfishing to, well, let's just say things some folks would rather stay hidden.
Okay, so how does a ship even go dark? It's not like turning off your car lights, right?
You'd think so, but it's surprisingly simple. It's all about the Automatic Identification System, AIS for short. Imagine a tracking system for every ship, constantly broadcasting its location, speed, even cargo. It's meant to prevent collisions, make shipping safer.
Right, so like a digital fingerprint that's always on.
Yeah, exactly. But some ships decide to switch that transponder off. Now, there are legitimate reasons for this, like evading pirates in certain waters, but more often than not, it's to hide something. Illegal fishing, smuggling, you name it, a dark vessel is up to no good.
So it's like going off the grid, but on the sea. What are some of the consequences of dark vessels? I mean, if it impacts things like illegal fishing, doesn't that affect everyone in the long run?
Absolutely. You might think, well, I don't eat that kind of fish, but this impacts the entire ecosystem, driving up costs, even leading to food shortages down the line. Not to mention the humanitarian issues. Often the crews on these vessels are essentially trapped, working in dangerous conditions with little to no pay. Modern-day slavery on the high seas.
That's heavy stuff. So we're talking about a global impact, potential human rights violations.
Yeah.
How on earth do you even begin to track down a ship that doesn't want to be found in the middle of the ocean?
That's the million-dollar question, and it's where things get really interesting. Forget sonar and radar. This is the age of AI stepping in to play detective. Researchers have developed a system using something called a traceformer.
Traceformer. Sounds intense.
It is. Imagine a superpowered pattern recognition machine. It analyzes the past movements of ships from all that AI data we talked about. So even if a vessel goes dark, the traceformer can make a very educated guess about its next move, based on past behavior, common routes, all that.
So it's like they've created a digital crystal ball, using past voyages to predict future ones, even if someone's trying to hide.
Precisely. But it gets even cooler. They've combined this traceformer with another type of AI trained on something pretty amazing: satellite images. We're talking about scanning the entire ocean from space for these tiny blips that could be our missing ship.
Wait, they're combing through satellite photos to find a specific ship? How does that even work? It's not like you can just zoom in and read the name on the hull from space.
You're right, it's not quite that simple. That's where the AI's real power comes in. Think of it like this. The traceformer gives us a possible route, a sort of most likely path our dark vessel is taking. But it's still a huge area to cover, right?
Right, the ocean is massive.
Exactly. So instead of having human analysts painstakingly examine every inch of satellite imagery, the AI creates what's called a probability heat map.
A probability heat map, what's that?
It's like taking a regular map and adding layers of color. The warmer the color, the more likely our ship is in that area, based on the traceformer's predictions. So now our analysts have a much smaller, more targeted area to focus on, saving tons of time and effort.
Okay, that makes a lot of sense.
Yeah.
But even if you narrow it down, how do you tell if that little blip on the satellite image is the ship?
Yeah.
Especially if they're actively trying to blend in.
That's where the second type of AI comes in. And this is where things get really wild. We've talked about the AI that predicts movement, but now we're talking about AI that can actually see and interpret images the way we do, but on a much larger scale, computer vision, they call it.
So like, we're teaching computers to see a satellite photo and know the difference between a tanker, a fishing vessel, and a cruise ship, even if they're all just white dots from that high up.
You got it, except it's even more specific than that. Think about the unique characteristics of a ship that's trying not to be found. Maybe they're running without lights at night. Maybe they've changed their paint job. Or they're intentionally sailing close to other vessels to mask their movements. The AI is trained on massive data sets of ships, both normal and those suspected of going dark.
So it's like giving the AI a crash course in all the ways a ship might try to camouflage itself at sea. But how do they even train it? Do they have people looking at millions of pictures of ships?
It's a combination of things. Sometimes, yes, it's humans analyzing and tagging images. Think, is this a fishing boat? Yes or no. But increasingly, AI is being used to help with this training process too. There are techniques where you can feed an AI a bunch of images and tell it these are all cargo ships, and it starts to learn the patterns on its own.
AI teaching AI. Feels very meta. So this image analyzing AI, what's it called?
It's not one specific name, but the technology behind it is usually something called a convolutional neural network, CNN for short.
CNN. Another acronym to add to the list. Is it as complicated as it sounds?
It can be, but the idea is pretty cool. Imagine how we as humans look at an image. We don't take it all in at once. Our eyes scan for patterns, edges, shapes, and our brains piece it together. CNNs are inspired by that same process.
Okay, I'm starting to get the picture. Literally.
Right. So the CNN breaks down a satellite photo into these little grids, analyzes each one for those telltale ship-like features, and then puts it all back together. The more images it analyzes, the better it gets at recognizing those patterns, even spotting the subtle differences between a ship trying to hide and one going about its business.
So you've got the traceformer giving you a possible location, and then this CNN acting like a superpowered set of eyes, scanning for anything that fits the description of our dark vessel. It's like a high-tech game of hide and seek.
That's a great way to put it. But it gets even more complex because, of course, those trying to hide are always coming up with new ways to avoid detection. It's a constant back and forth.
You're saying even with AI, it's not a guaranteed win. What are some of the ways ships are trying to outsmart the system?
We're talking everything from low-tech solutions, like special paint that makes them harder to spot on radar, to high-tech tactics like AI spoofing. Imagine creating fake AI signals to make it look like you're somewhere else entirely, throwing the whole system off your trail.
Wow, so it's like a digital game of cat and mouse. These dark vessels are getting pretty creative. What's the next step in this technological arms race? What are researchers developing to stay one step ahead?
That's a great question, and this is where the line between reality and science fiction starts to blur. We're talking about integrating even more data sources, things like social media posts, news reports, even weather patterns, to paint a more complete picture of what's happening at sea.
So it's not just about the ship's movements anymore, but about creating this whole web of information to catch them out. Fascinating. But before we get too far ahead of ourselves, let's rewind a bit. I want to make sure I understand how this traceformer actually learns. You mentioned something about training montages earlier, and that it needs a special kind of data to get smarter.
You're right. Just like any good detective, these AI systems need to be trained. And that training relies on data. But not just any data, it has to be high-quality, labeled data. Think of it like this. Imagine you're teaching a kid to ride a bike. You wouldn't just give them a helmet and push them down a hill, right? You'd start with the basics. How to balance, how to pedal, how to brake. And most importantly, you'd show them what a successful bike ride looks like.
Okay, I see where you're going with this. So the data is like those training wheels, giving the AI the support it needs to eventually ride on its own.
Exactly. And just like you wouldn't teach someone to ride a bike on a busy highway, the data we use to train these AI systems has to be carefully chosen and prepared. In the case of the traceformer, that means feeding it tons and tons of AI's data, but here's the crucial part. This data isn't just a jumble of coordinates and timestamps. It's been meticulously labeled with the actual future movements of those ships.
So it's like saying to the AI, here's where the ship was, and here's where it went next. Now you try to connect the dots.
Precisely. Think of it like flashcards for a detective. One side shows the ship's past movements, the other side reveals its future path. The traceformer goes through these flashcards, making connections, learning patterns, and gradually getting better at predicting those future movements on its own.
And the more flashcards it sees, the better it gets at recognizing those patterns, even if a ship tries to deviate from its usual routine.
You got it. It's all about pattern recognition on a massive scale. But gathering and labeling all that data is a huge task in itself. Remember, we're talking about potentially millions of ships, each with its own unique history of movements. It's a monumental effort, often involving a combination of human analysts and some clever automation tricks.
Okay, so we've got our meticulously labeled data, kind of like a giant detective's case file. What happens next? How do you actually train the traceformer using this information?
Well, that's where things get a bit more technical, but I'll try to keep it simple. Imagine the traceformer as this incredibly complex machine with millions, sometimes billions, of tiny knobs and dials, each one representing a different variable or parameter. Initially, all these knobs and dials are set to random values. The model has no idea what it's doing. It's just a bunch of random connections.
Okay, so kind of like those old radios where you had to fiddle with the dials to find the right frequency.
Perfect analogy. Now, the goal of training is to adjust those knobs and dials to find the perfect combination that allows the model to make accurate predictions about ship movements.
But how do you find the perfect combination? There must be an infinite number of possibilities.
That's where the labeled data comes in. Remember those flashcards? We start by feeding the model a small batch of that labeled data, the ship's past movements and the corresponding future movements. Initially, its predictions are probably going to be way off, like throwing darts at a map while blindfolded.
Makes sense, it's still learning.
Exactly. But here's where the magic happens. Every time the traceformer makes a prediction, we compare it to the actual answer on our flashcard. The difference between its prediction and the truth is called the loss.
So the loss is like a measure of how wrong it was.
Exactly. And here's the really clever part. The model uses this loss to adjust those metaphorical knobs and dials, those millions of parameters, ever so slightly in the right direction. It's like the model is saying, okay, I was off by this much, let me tweak things a bit and try again.
So it's learning from its mistakes. Kind of like how we get better at something with practice.
Exactly. And we repeat this process thousands, even millions of times, feeding the model different batches of data, calculating the loss, and adjusting those parameters until it gets really, really good at predicting where a ship is going to go based on its past behavior.
It's like a crash course in maritime movements, but instead of textbooks and lectures, it's all data and algorithms. It's fascinating how this all works, but we're talking about some serious computing power here, right?
Absolutely. Training these deep learning models requires enormous amounts of computational resources. We're talking about powerful computers, often working in parallel, crunching through all that data for hours, even days on end.
I can imagine it's like building a super brain dedicated to understanding the movements of ships. But even with all this incredible technology, there's still the human element, right? It's not like we're just handing over the reins to these AI systems and calling it a day.
You're right. This is where we get into some of the most interesting and complex aspects of this whole field, because ultimately, as advanced as this technology is, it's still just a tool. And like any tool, it needs to be used responsibly, ethically, and in a way that complements, not replaces human judgment.
So it's about finding the right balance, the right way for humans and AI to work together effectively. How does that play out in practice?
Well, let's take the example of a human analyst looking at those probability heat maps we talked about earlier. The AI might highlight a certain area as highly likely to contain a dark vessel, but it's ultimately up to the human to look at the bigger picture. Maybe there's a logical explanation for a ship being in that area, something the AI didn't pick up on, or maybe the AI flags a vessel as suspicious, but upon closer inspection, the analyst realizes it's just a fishing boat experiencing technical difficulties.
So the human acts as a sort of filter, using their experience and intuition to separate the true positives from the false alarms.
Exactly. It's about leveraging the strengths of both. The AI can process vast amounts of data, identifying patterns and anomalies that a human might miss. But the human brings to the table things like context, critical thinking, and an understanding of the nuances that might not be captured in the data.
It's fascinating how important that human element remains, even as technology continues to advance at an incredible pace. So we've got the AI making predictions, the analysts narrowing down the search. What happens when they think they've found something?
That's when things get really interesting and potentially dangerous, because now we're talking about what happens when those dark vessels are confronted.
Okay, this is getting good. We're talking about high seas showdowns, right? Tell me more about how this all plays out in the real world.
Imagine this. A Coast Guard vessel, guided by the AI's predictions and the analyst's assessments, approaches a ship suspected of illegal fishing. But approaching these vessels is not without its risks. The crews are often armed, tensions can run high, and there's always the risk of a dangerous confrontation.
So there's a whole other layer of complexity and risk that goes beyond the technology itself.
Absolutely. And this is where the human element becomes even more crucial. The officers on those patrol vessels aren't just there to enforce the law. They're also trained negotiators, diplomats, and sometimes even social workers, trying to de-escalate situations, gather evidence, and ensure the safety of everyone involved.
It's a reminder that even in this age of advanced technology, maritime security still relies heavily on human skill, courage, and judgment.
Precisely. It's a fascinating interplay between the virtual and the real, the digital and the human. And as technology continues to evolve, I think we'll see even more creative and unexpected ways for humans and AI to work together to address the complex challenges facing our oceans.
This has been absolutely fascinating. It's like peeking behind the curtain of a high-tech detect agency, but one that's operating on a global scale with incredibly high stakes. And it sounds like this is just the beginning. What does the future hold for this technology?
Well, the possibilities are really quite extraordinary. Imagine a future where Imagine a future where these AI-powered systems aren't just reacting to dark vessels, but are actually predicting their movements.
So we can prevent illegal activities before they even happen.
Exactly. Imagine a network of autonomous drones patrolling the oceans, their AI brains working in unison with human analysts to safeguard marine protected areas and intercept smugglers.
Before they even reach their destinations.
It's like something out of a science fiction novel.
It really is, but it also raises some interesting questions. What happens in a world where we have this level of surveillance on our oceans? What about the potential for misuse, for these technologies to be used for, well, less than noble purposes?
That's the million-dollar question, isn't it? As with any powerful technology, there's always the potential for misuse. But I believe that by having these conversations, by being aware of the potential risks and working to mitigate them, we can harness the power of AI for good. It's about finding that balance, that sweet spot where technology enhances our abilities without compromising our values.
It's a lot to think about. This whole deep dive has been a real eye-opener. From the technical intricacies of AI to the vast geopolitical and ethical implications.
It's been a pleasure sharing these insights with you.
The pleasure was all mine. And for our listeners, if this deep dive has sparked your curiosity, if you're left wondering about the unseen world beneath the waves and the cutting-edge technologies being used to protect it, well, we've just scratched the surface.
There's a whole ocean of information out there waiting to be discovered.
So, to our listeners, until our next deep dive, keep asking questions, keep exploring, and keep your eyes on the horizon.